All right, in this last screencast on acid deposition, you're going to be looking at the regional effects of acid deposition on societies, and I'm also going to just highlight pollution management strategies for acid deposition. I won't go into a lot of detail, but you're going to need to be able to use both of these things on an essay to finish up this activity. All right, so first of all, the regional effects of acid deposition. One thing is that dry deposition tends to fall close to the source, as I mentioned in an earlier screencast, and wet deposition actually can occur at longer distances from the source of the primary pollutants. And that can actually be a pretty big deal because downwind areas of these industrial regions tend to be the most affected. So if there's prevailing winds that are going in a constant direction, you're going to see the most acid rain happening downwind from these big industrial areas. And those areas might be in a different country even, or a different region than, of course, the source of the pollutant. And so that can cause some conflicts and has resulted in a lot of international treaties. So here are 8 areas that are affected pretty severely by acid rain: the east coast of North America, Europe, especially near the north. There's a lot of industrial areas here that are responsible for this. And then the emissions can move downwind from those areas too, leading to acid rain outside of the major industrial areas. And then some areas actually have more sensitive soils. They're thinner, and if they're made of granite, basically if they're not made of limestone, they tend to be more sensitive to those acidic conditions. So where we've gotten some issues in the past is Scandinavian forests and lakes were deeply affected by acid rain that was originating in Britain, Poland, and Germany, with prevailing winds taking a lot of that deposition there. And that's still happening today. In fact, I have an article that I'm going to have you read that's kind of looking at, well, maybe we've been dealing with a lot of those sulfur issues from the power plants, because now we have scrubbers and things that can take that sulfur out. But because of cars and agriculture, they're still getting pretty severe acidity in the lakes and affecting their conifer forests. Canada and the US had a major issue that they finally had an agreement on in the mid 1980s. And we saw that all that industrial emissions in the East Coast was affecting Canadian forests, as well as their lakes, becoming quite acidified. And again, you've got to think that they're not just losing the forest, but they're also going to lose a lot of the other species, like fish species and other things. They ended up coming together with an agreement to be able to lower those emissions, but still, these major issues, we thought that we were kind of done when we invented scrubbers and got rid of a lot of the sulfur, but now all the high density car traffic and the intensive industrialized agriculture is exacerbating the issue with acid rain today. And you'll see China can impact most of Southeast Asia as well. So there's issues that kind of come cross border. And I want you to dig into one of those just so you can use it as a case study in an essay that might come up about acid rain. And then looking at the pollution management model, remember there's the 3 stages for it. Your book outlines some nice strategies, right? So in the beginning, we're going to be, how do you stop the pollutant in the first place? So they've got some ideas about, they're similar to the ones from photochemical smog, right? You're going to reduce using fossil fuels. So you're going to use public transport. So you're going to, educate people with education campaigns, turning off your lights. Like, we want to have less energy uses of fossil fuels. And you might replace fossil fuels with other types of renewable energy sources too, right? And they also have low sulfur fuels that can be used even if you are still using if you are still using sulfur containing fuels. Or fossil fuels, you can get the sulfur removed. Okay. And then the next level, right? You've got regulating and reducing the pollutants. So now this is basically meaning, okay, we're still going to produce the pollutant, but we need to be able to limit how much is getting out into the atmosphere. How do we do that? And there's some really nice cleanup technologies for the industrialized, like coal-fired power plants, that can actually scrub and pull a lot of that sulfur out of the exhaust coming from the end of the pipe. So there's in these chimneys, they've got these scrubbers that can remove a lot of that sulfur dioxide. So it's being created, but it's not being let out into the atmosphere. They keep it there and trap it. Also, the catalytic converter that we saw in trying to convert nitrous oxides back into nitrogen gas, that was also used for tropospheric ozone, right? And photochemical smog, that is a similar way to kind of keep that from getting out in the atmosphere. And then lastly, we screwed it up. We've let it, the damage is done. How can we fix it? You can actually put lime in, it's alkaline. You put that into lakes and rivers to be able to neutralize the acid. And if it's really damaged, you can restock the fish, right? And other things like that. Replant the trees, lime the forestry plantations. And again, you can plant more trees, the ones that have been damaged. They also mention on here international agreements. I would actually say that international agreements would work at all three levels, right? You could have international agreements that can get you to reduce at all three levels. So I wouldn't say it's only for cleanup and restoration. So I would probably put that in at all possible levels. Okay, so you need to be able to talk about, acid rain and how it can cause some issues cross borders. I'd like you to have some sort of case study in possible solutions that had come up with, as well as being able to look at managing acid deposition through trying to reduce those primary pollutants at all three levels.